In 11.3, we're going to write rules for geometric sequences and find sums of geometric sequences. All right. In 11.2, we looked at arithmetic. All right, where we had a common difference. All right, that was our d value. All right, and now we're looking at a couple of different sequences. All right, a couple of different things. All right, so in our paper here, all right, you have your vocabulary. Now, before, with arithmetic sequence, we had a rule, and for geometric sequences, we have a different rule. All right, and different values. All right, our rule for a geometric sequence, all right, is a sub n is equal to a1, and we know a1 to be the first term in the sequence, times r, all raised to the n minus 1. All right, our rule's a little bit different. All right, now our r value is our common, what we call common ratio. All right, and well, a ratio is another way of writing a fraction. And so just like with the arithmetic sequence, when we found d, all right, and our first term a sub 1, we could write the rule. All right, in this case, we want to still find that first term, and then we want to figure out what the common ratio is. All right, so we're going to look at that first. All right, so writing a rule for the nth term. All right, there's an example there. If you want to pause and you want to take a look at the example, you can. We're going to go right to the problems. All right, and kind of try to explain it from the problems. Now, somewhere on here, and basically this is the first video lesson that we're doing. So kind of how we want to format this is to kind of do the problems with me as you go along. You should kind of try to figure out what's going on. All right, so before, when we were looking at these sequences, we first tried to figure out whether or not they were arithmetic. Well, in this case, we're trying to figure out whether they're geometric. And for them to be geometric, we have to be multiplying, all right, instead of with arithmetic where we're either adding or subtracting a number to find that, we're finding that common difference. Here we're finding the common ratio. All right, now one way of finding the common ratio is to take, let's say, like the second term and divide it by the first term to figure out the value. All right, now the third term divided by the second term. All right, so we want to take a term and divide it by its previous term to figure out the r value. Now, if it's a nice set of numbers like number 1, then we're just going to say, well, how much are we multiplying by to get the next number? All right, 4 times what gives us 12? 3. All right, 12 times 3 gives us 36. All right, we could check the next number to make sure we're okay, but we're seeing that instead of finding that common difference value, we're finding the common ratio value. All right, and so in this case, our common ratio, all right, is, and we don't write a d, we write r. All right, our common ratio value is 3, because that's what we're multiplying by for that problem. All right, now you can look at the sequence and figure out what your first term is equal to. All right, so a sub 1 is equal to 4. All right, now once I have those two things, we're pretty much done as far as a rule. Now, going back up to your rule, all right, which is a sub 1 is equal to, a sub n is equal to a sub 1 times r to the n minus 1. So this is a little bit easier to write a rule for than the arithmetic sequence. All right, so let's write the rule. An is equal to a sub 1 r to the n minus 1. All right, and we just want to plug into that rule. All right, so we're going a sub n is equal to, what is a1? A1 is 4. All right, to the r, which is 3, or times r, which is 3, to the n minus 1. And there's nothing to simplify. You're done. All right. Now, please remember that you cannot multiply that 4 and that 3. All right. The reason why you can't, because there's an n minus 1 in that as an exponent. All right, and if you were doing your order of operations, which some of you call PEMDAS, some call Please Excuse My Dear Aunt Sally, I say purple eggplants make delicious afternoon snacks. All right, you can't multiply these without evaluating that exponent first. So you're done. Please don't go 4 times 3. Let's do another one. All right. 1 times something gives you 6. 6 times something gives you 36. 36 times something gives you 2. All right. And we look at this. Well, 1 to 6 is times 6. And then we check the rest of them. Yes, 6 times 6 is 36 and so forth. So we see that our common ratio value, R, all right, is equal to 6. Our first term in this sequence is 1. All right, and we have everything we need to write the rule. Well, let's write an is equal to a1 times r to the n minus 1. All right, and so our rule is an is equal to, well, 1 times 6 to the n minus 1. Done with that. All right. I would like you to pause the video for a second and try number 3. All right. And then unpause once you finish to see if you can get the right answer. All right. Now, if I'm ever looking for R and I'm not sure, I'm going to take a term and then divide it by its previous term. So R is negative 6 over 2. All right. That gives me negative 3. I can check it by doing that again. 18. R would be 18 over the previous term. Negative 6. That's also negative 3. So we know that we're good with our R value. All right. If we just in case we weren't sure. All right. That R is equal to negative 3. All right. So now that we have that and we know that our first term is equal to 2, let's write the rule. All right, the rule is a sub n is equal to the first term times the common ratio to the n minus 1. All right, and so we want to go a sub n is equal to 2 times negative 3 to the n minus 1. You can pause again. Pause real quick and try number 4. I'm going to keep going. All right, 7 to 14. Or you can say 14 divided by the previous term 7. Either way, R is going to equal 2. All right, and your first term is equal to 7. All right, so write your rule. An is equal to a1 times r to the n minus 1. All right, and that's going to give us a sub n is equal to 7 times 2 to the n minus 1. All right, so first page of notes done. All right, next set of problems. Well, given a little different, same stuff, just given different values. All right, now just like in arithmetic where we were given, let's say like the 13th term is equal to something. All right, this works in the same fashion where you want to write a rule. All right, depending on the information given. All right. So if you want to pause and look at the example, please do so. All right, we're going to start with number 5, which is a very simple problem. Not much to do because they give you the first term and they give you R. All right, so we don't have to figure them out. All right, in this case, we write our rule again. An is equal to a1 times r to the n minus 1. All right, and so we know those two things. All right, so we go a sub n is equal to 2 times negative 1/3 to the n minus 1. You're done. All right. Number 6. All right, they give us a little bit, a little different information here. All right, they tell us that the 5th term, all right, which is n, and it's when they tell you that the 5th term is equal to 3, then they're saying n, when a sub n is equal to 3, n is equal to 5. All right, that's what that's saying right there. All right, when it says the 5th term is equal to 3, we're saying that when the excuse me, when a sub n is equal to 3, n is equal to 5. All right. And in this case, they tell you what the common ratio is, which is -1. Now, there's several ways to figure this out, all right? But we want to take the information given and plug the information into the rule. All right, so we're going to write the rule. A1 times R to the n minus 1. We're going to fill stuff in. All right, we know what AN is. That's 3. All right, we don't know what the first term is equal to. All right, we know what R is equal to. R is -1. All right, and we also know what N is equal to. That's 5. So 5 minus 1. All right, in parentheses. Now, from there, we want to solve for the first term. If we can figure out the first term, we can write the rule. All right. So let's go ahead and do our order of operations to solve. 5 minus 1 is 4. All right. -1 to the 4th power is equal to 1. All right. And in this case, 1 times the first term is just the first term. And so they tell we've solved and we find that the first term is equal to 3. All right, just by plugging into the rule. Now that I have the first term and I have R, all right, I can write the rule itself. All right, so let's write the rule over here. All right. At the beginning, you guys know that I'm going to write the rule first. All right, and I'm going to plug into the rule. So A sub n is equal to the first term, which is now 3, times -1 to the n minus 1. All right. All right, number 7, very similar to number 6. All right, we can keep number 6 there a little bit. All right, well, we can kind of use it. All right, circle this. What term is that? All right, that's the third term, so it is equal to -12. So we say that A sub n is equal to -12 when n is equal to 3. All right, and they give us R is equal to -2. So same type of problem. We're going to go A sub n is equal to A1 times R to the n minus 1. All right, we're saying that -12 is equal to A1 times R, which is -2 in this case, excuse me. -2, kind of ugly there, sorry, rodent pen. All right, to the 3 minus 1. All right, what's 3 minus 1? All right, that's 2. All right, we still got to take care of exponent. So -2 squared is 4. All right, and remember we're solving for A sub 1. So we're going to divide both sides by 4. All right, and the first term is equal to -3, -12 over 4. All right, so we got that. All right, from there, let's finish the problem up and let's get our rule. So A sub 1 is equal to A1 times R to the n minus 1. All right, plugging in, A sub n is equal to -3 times my R value, which is -2, to the n minus 1. And we are done. All right, let's keep it going. All right, so finding the sum. Finding a sum. All right, this is where you need your calculator. You need a calculator out. All right, we're going to go back here and we're going to pull this. All right, there's no, I know for arithmetic sums, we used a different formula than was on the notes, and we added a formula. There's no other formula for geometric. All right, so we're going to pull that formula. All right, so we say that, and we're just going to write it right over here, that the sum of an nth amount of terms is equal to the first term times no way. All right, so now we're finding the sum of the first n terms of the geometric series. So it's very similar to what we did before, different formula for geometric. So it's going to be important that when we put all this together, you know if we're dealing with arithmetic or geometric. All right, so in this case, we have 2 plus 8 plus 32 plus 128 plus ... All right, and they tell us that n is equal to 12. All right, so we're looking for the sum of the first 12 terms. All right, now as long as we can figure out what the first term is and what our common ratio r is equal to, we can solve this. So we're going from 2 to 8, 8 to 32, 32 to 128. Remember, you can just, if you got number sense, you can see that every term we're multiplying by 4. If you can see that, then that's great, all right, of the series. All right, if you can't, you're going to go 8 over 2, which should equal 32 over 8, and so forth, all right, and it'll all equal to 4, all right, and that was showing that, all right, right there. Okay, so r is equal to 4 for this. All right, and our first term is equal to 2. All right, and so we want to use that rule, all right, the series formula, all right, for geometric. All right, so let's start plugging into this. We got everything we need. All right, gets a little tricky sometimes for some people. All right, but we're saying that we're trying to find the sum of the first 12 terms. All right, we say A1 is 2. All right, 1 minus our R value. All right, our R value is 4, so it's 4 to the 12th. All right, divided by 1 minus 4. All right, so we just plugged everything into that form. All right, and then we want to evaluate here a little bit. All right, not a little bit, but all the way. All right, so we got 2 times, in the top, we're going to go 1 minus, and we're going to use our calculator, all right, to find out what 4 to the 12th is equal to. All right, so we go 4 caret is right above the division sign. All right, 12. All right, it should give us a pretty big number. All right, so that's our number. You can pause it. I'm moving it out to the side. All right, that's 16,777,216. And yep, it's that big. All right, and then 1 minus 4 is a negative 3. All right, keep it going. All right, if I evaluate my numerator, all right, I get negative 167772115 over negative 3. All right, from there I go back to the calculator. All right, negative 167772115 divided by negative 3. All right, that gives us 5 million. So now we have 2 times 5,592,405. All right, times 2. All right, so now that you have that, just multiply by 2. All right, and then that gives us a pretty big number again. Looks like 11,184,810. All right, is our final answer. Now, these numbers are probably going to, especially if it's they're all positive or they're all negative, it's going to be a pretty really big number, a really small number, all right, when you're finding the sum of geometric series. And we'll talk about how things grow geometrically, or in our case, exponentially as the semester goes on. All right, and the final question, number 9. All right, you see it's going positive, negative, negative. All right, and so we go from 1 to -6. Our R value is, what do you think? Look at the numbers, -6. A1 is 1. All right, hopefully it's a little easier, maybe not. All right, they want the sum of the first 9 terms. All right, so let's plug in, let's write the formula. S sub n is equal to A1 times 1 minus R to the n over 1 minus R. All right, plugging in, excuse me, is 1 times 1 minus 1 minus a -6 to the 9th all over 1 minus a -6. All right, good job, good idea to put that in parentheses like that. All right, and then let's evaluate this. All right, whatever we have here is going to be times 1, so we're not going to worry about the 1. It's going to be itself. All right, we have 1 minus, and then -6. We want to go -6 to the 9th. All right, that gives us a -100777696 all over. You see this is 1 minus a minus, so it's plus, so it's 1 plus 6. Now you see that minus minus, that's also going to become a plus. All right, from here, this is 100777697 all over 7. All right, we want to do that one in the calculator. All right, 100777697 divided by 7. All right, and that's going to give us 1,439,671. All right, and that is all of your notes.